Stand at the bottom of a gorge in southern China and look up. The bridge crossing it sits higher above you than a cruising helicopter. The road deck hangs 565 meters over the river, taller than the Empire State Building, taller than the Eiffel Tower, higher than any bridge anywhere in Europe or the Americas. And it's not even close. The second highest bridge on Earth is also in China. So is the third. 9 of the 10 highest bridges in the world sit inside one country. That's not a fluke of geography. It's the result of a country deciding over and over that impossible is a starting point, not a stop sign. Today, we're looking at 4 projects: a bridge, a railway, a desert highway, and a canal that literally moves rivers, that engineers said couldn't be built. They got built anyway. The bridge above the clouds. The Beipanjiang River carves through a gorge in Guizhou province with walls that drop almost straight down for hundreds of meters. Before 2016, crossing it meant a road trip of over an hour, winding down into the canyon and back up the other side, to cover a distance you could walk in under an hour as the crow flies. Engineers faced a genuine dead end. The gorge was too wide for a single arch, too deep for support towers rising from the valley floor, and shrouded in fog and high winds for much of the year, making construction itself dangerous. The solution was a cable-stayed design with 2 towers, each over 200 meters tall, planted directly on the cliff edges, holding a deck spanning 1,340 meters in open air. Crews worked from platforms suspended by cable above a canyon they sometimes couldn't even see across because of fog. Concrete had to be pumped up the height of a 50-story building, which required custom equipment because nothing off the shelf could handle that pressure. When the Doog Bridge opened, the hour-long crossing became a 60-second drive. A geographic barrier that had shaped 2 communities' entire relationship for generations basically disappeared. The railway that shouldn't work. The Tibetan Plateau is the largest high-altitude landmass on Earth, an area roughly the size of Western Europe, averaging over 4,000 meters in elevation, where unacclimated visitors can get altitude sickness within hours. Underneath much of it sits permafrost, ground that looks solid, but is really just soil glued together by ice. Put anything warm on top of it, like a railway embankment, and it thaws, buckles, and eventually collapses. That permafrost problem is exactly why, through the 1980s and 90s, engineers who studied a Lhasa railway route kept concluding it wasn't feasible. Before 2006, reaching Tibet's capital from the Chinese interior by land meant a multi-day journey across terrain that shut down seasonally. China built the railway anyway, nearly 2,000 kilometers of track, almost half of it laid directly across permafrost, cresting at 5,072 meters above sea level, the highest railway point on the planet. The fix wasn't one trick. It was a whole toolkit used together for the first time at this scale. Elevated viaducts that lift the track clear of the frozen ground below. Thousands of passive heat pipes along the embankment that pull warmth out of the soil and vent it into the cold air. And custom insulation layers to block heat transfer entirely. The passenger cars are pressurized like an airplane cabin, with oxygen piped to every seat, because the air at the highest points doesn't carry enough oxygen to breathe comfortably. The trip that used to take days now takes about 22 hours, and the permafrost engineering developed for this line has since been adopted for railway construction in Russia, Canada, and Scandinavia. The highway. Through every kind of danger between Chengdu and Lhasa, engineers are cutting a new highway through a stretch of terrain that manages to concentrate almost every geological hazard that exists. Active earthquake zones, landslide-prone slopes, gorges that plunge thousands of meters, and glacier runoff that reshapes the ground with the seasons. The existing road through this corridor has been one of the most dangerous in the world for decades, killing dozens of drivers a year and taking up to 2 weeks to drive end-to-end in good conditions. The new route treats each hazard as a design problem instead of an unavoidable feature of the landscape. Hundreds of tunnels bore straight through mountains instead of climbing over them, and bridges carry the road above unstable slopes instead of crossing through them. One completed tunnel already replaced a high-altitude pass that used to close under snow for months every year, turning a seasonal barrier into a 2-lane tunnel you drive through in minutes any time of year. When the full highway is finished, a 2-week trip becomes a 2-day one. The mountains haven't moved. What they mean for the people crossing them has changed completely. A highway that needs to stay alive. The Taklamakan Desert covers an area bigger than Germany. True shifting sand dunes, some over 200 meters tall, that migrate with the wind and bury anything in their path. When China first proposed a road across it, the standard engineering answer was that the dunes would bury it within a year, and that keeping it clear would never be worth the cost. The fix wasn't to fight the sand. It was to stop it from moving in the first place. Along the entire highway, crews planted a belt of drought-resistant shrubs on both sides, watered by wells drilled into the desert floor. Where the roots hold the sand, the dunes stop migrating, and the road survives underneath them. It's a highway that depends on a living ecosystem to keep existing, maintained by stations along the route whose entire job is keeping that vegetation belt alive. After the first crossing opened in 1995, a second and third followed, and by 2022, engineers had completed a full ring road circling the entire desert. Over 2,000 kilometers of highway connecting communities that had previously only been reachable by camel or aircraft. Moving rivers instead of praying for rain. China's water problem was never really about scarcity. It's about location. The Yangtze Basin in the south carries roughly 80% of the country's surface water. The basin around Beijing, home to hundreds of millions of people, carries around 1%. The imbalance is old news. Even the Grand Canal, built 1,400 years ago, was partly an attempt to solve it. The modern answer dwarfs it. The South-North Water Diversion Project's middle route alone moves close to 9.5 billion cubic meters of water a year, 1,400 plus kilometers from a reservoir in Hubei province up to Beijing, including one stretch where the canal doesn't cross the Yellow River. It tunnels straight underneath it, water passing beneath water. Building it meant raising a dam 14 meters and relocating over 300,000 people from communities that would be submerged by the larger reservoir. A resettlement effort finished on schedule. None of these 4 projects made economic sense on paper before they existed. Every one of them was called impossible by the engineers studying it, right up until it got built anyway. The pattern underneath all of it is the same. Infrastructure that waits for demand to justify it, versus infrastructure built to create the demand in the first place. Whichever side of that argument you land on, the bridges, the railway, the desert highway, and the canal are already standing. Which one of these would you least want to be the engineer on? Let me know in the comments.